Today is going to be about scatter plots. You can see two of them right here. A scatter plot is a way of graphing a bunch of data, but you can't just put any data in a scatter plot. Generally, it's going to be where both variables can take many values. And that means that you're never going to really see a scatter plot in an experiment, only in an observational study. Because in an experiment, one of your variables would be how much, I'm going to give people different amounts of apple juice and we'll see how long it takes before they have to go to the bathroom. You are not going to give them 10 different treatment groups. You're going to have 3 treatment groups. Definitely not 50 treatment groups. So it's not going to be a continuous sort of thing. You'll only have 3 bunches all vertically, and that's not proper for a scatter plot. Scatter plots you're going to see when both things are continuous, and that means basically observational studies. So, earlier today, I asked everybody to hand in their grades and their GPAs. And what we're going to try to figure out if there's any relationship between them. I just told you that we don't do experiments. We don't do scatter plots really with experiments, just observational studies. And we can't, and that means no cause and effect, but we can still see relationships between things. And as you will see later in this chapter, use one to predict the other. So I'm going to, at the end of the slide, show you the data from this class, the 2016-2017 AP Stats section that I taught, or am teaching, and and we'll see what the data says. Yeah, so here are some scatter plots. Oh look, some more scatter plots. In these two, the relationship isn't as clear as in the first one or two. And here it's even fuzzier. Here you can't even tell if it's going up or down. Here it's not in a straight line. Usually we'll be working with straight lines, data that fits more or less into a straight line, but I wanted to include one example that wasn't. There's going to be a bunch of things we describe each scatter plot as being, like what relationship do you see? Here I see a quadratic relationship, or possibly an absolute value relationship, but the point is it's curved, it's not a straight line at all. Let's have a look here. Okay, so today we're going to talk about the structure of a scatter plot. First of all, what do you graph as your x-axis and your y-axis? Why, and do you do that? And what words are used to describe what you see? So, let's take SATs and grades as our example for this. Explanatory and response variables. We can't use cause and effect because it's not generally for experiments, it's for observational studies. But we do have one thing we think can explain the other, and I'll explain what that means like this. Let's say I want to predict, Brittany Lynn did not take the SATs yet, but she already has her GPA. So can I use her GPA to predict what her SAT scores will probably be, more or less? That's what we very often use scatter plots for. So we're going to use one variable to explain what we expect from the other. The explanatory is the variable we're going to use to explain. In the case of Brittany Lynn, we're going to use the explanatory variable of her GPA to try to predict the response that she's going to get from the SAT. X variable, Y variable. That doesn't mean cause and effect, it means we're going to try to use one to predict or explain the other. So just like you explain a distribution with cus, center, spread, unusual features, shape, you describe a scatter plot by noting these things about it. If there are any outliers that really stand out, if the shape is linear or something else, whether it's a strong, very clear relationship or whether it's not so strong, and whether it's going up, whether the two have a positive slope or a negative slope, whether more of one thing leads to more of the other thing. Take for example this over here. We see that as husband's age is higher, wife's age is also higher. So it tends to be that older men are married to older women, as a general rule. There are exceptions. Here's a couple where the wife is older than the man. Here's a couple where the husband is older than the wife by quite a bit in each of these cases. But it's not an enormous difference. This is a pretty good, pretty solidly reliable relationship. You can generally guess the wife's age within a few years if you use the husband's age. And this is set up to do just that, using husband's age as the explanatory variable and wife's age as the response variable. So, like, in theory, this would be used to say, well, you met a 60-year-old man who says he's married. I bet his wife is about 58 years old. Yeah, so how do you describe this? First by direction, it's a positive correlation. Then by strength, this is a pretty reliable relationship. This is a strong positive correlation. I don't see any outliers. And what was the other thing? Let's see. Doofus. It's silent U, right? Direction, unusual features, form, and strength. So its form is linear. Its strength is strong. So this is a strong, positive, linear correlation. Strong, because it's reliable. Linear, because it doesn't seem curved or anything. Positive correlation, because it's going up when one thing goes up when the other thing goes up, right? Positive slope. More of one thing means more of another. On the other hand, this is a moderately strong negative correlation with no outliers. And what did I miss? Strength, form. Is it linear? More or less linear. So this is a moderately strong negative linear correlation. Correlation, you've seen before. I think I've told you it's more or less a synonym for association, like more of one thing happens with more of another. I guess not, maybe I just use the word association, and I use that differently. So correlation is when two things tend to happen at the same time. More of one thing leads to more of another, or more of one thing leads to less of another. And yes, that word is going to be used in this chapter a lot. Here are two somewhat weaker correlations. This correlation is actually still also pretty strong. So I'd call this a fairly strong negative linear correlation. And this would be a weak positive linear correlation. When default linear, unless you can see some sort of curve, you can either say linear or fairly linear. Yup, this is a fairly strong quadratic correlation. It wouldn't be positive or negative. You could say this is, they probably won't bring these up, but if they ask you if the correlation is strong, you'd be like, well, it matches a parabola strongly. Is it positive or negative? Well, it's just sort of it's neither upwards nor downwards consistently. So you couldn't say this is positive or negative correlation. That looks like very weak positive correlation. Linear, probably. Default to linear unless there's reason to doubt it. Like in that parabola one. I already did that. Okay, here's the data from our class. What do you see? Consider. Give me your words and I'll give you mine. Ignore this dot. This is just the key. Alright, here's what I would say. I would say, my guess is a very weak positive correlation. That is, students with higher GPAs seem to tend to, on average, have higher SAT scores than those with lower grades, but it's hardly any sort of reliable indicator. So it is a weak positive correlation. Is it linear? Sort of spreads out over here, but maybe it's just because we're missing a point like there and another point there. I would call this just, I don't know if I'd use the word linear. but they probably won't ask you if it's linear because it's just, that's not the sort of thing where they want to put you on the edge. They want the answer to be obvious if you know what you're looking for. So they wouldn't ask you if this is linear or not, but when in default, say sure it's linear-ish. And I think that's it for this first lesson. Yay! No, I don't think I've explained R. Let me just check my cheat sheet. Which one? Oh no, where's my other cheat sheet? Ah! Okay, great. I'll skip to the next video.